Today we're gonna start with the similar Hamiltonian system, but with different examples because this topic is really important. So today I'm gonna consider Hamiltonian system, but with different example is we know the Hamiltonian system. Okay, so we are considering the system x dot is equal to y and y dot is actually x minus x square. Okay, so we're gonna start similarly that we know that 0 0 and 1 0 are equilibrium points. Okay, so that's for sure. And similarly the Jacobian matrix is 0 1 and 1 minus 2x and 0. Okay, but Jacobian matrix at 0 0 is actually 0 0 or 0 1 1 0. Okay, so if we see that lambda 1 2 is actually plus minus 1, so it is settled. So 0 0 is settled. Okay, we know that this is unstable. But if we see this 0 0, okay, 0 1 0, okay, so if we see the other equilibrium point which is 1 0, then we know that this is 0 1 minus 1 0 and lambda 1 2 is nothing but this is plus minus iota, so 1 0 is center, and because the real part is 0, so we cannot determine the stability. In other words, we can say the center can be stable and unstable, but how? So actually we're gonna use the Hamiltonian, and we will find it by from this system, the given system, and then we will actually use that Hamiltonian to draw the phase portrait, and then we can see the solution behavior. Okay, so to find Hamiltonian, okay, so what can we do? So to find Hamiltonian, to find H, okay, we will use Hamiltonian equation. So we know that x dot is equal to partial h over partial y. So this means that x dot is y. So from here we can see that hxy is nothing but y squared divided by 2 plus h is a function of x. Now if we take the derivative of this h with respect to x, we know that this is h prime of x. But if we see that y dot is actually minus partial h over partial x, so this implies that partial h over partial x is minus y dot, but y dot we know that it is minus x squared, so this will be x squared minus x. So in other words, we can say that h h prime of x is actually what was this? This was actually, we saw that this was x square minus x. Okay, so x square minus x. Okay, and then this is definitely x cube divided by 3 minus x square divided by 2 plus c. So my h of xy is nothing but this is what? So is we saw that this is y square divided by 2. Okay, y square divided by 2 and plus x cube divided by 3 minus x square divided by 2 plus c. Okay, so we can ignore c because for different c we will have different h. So we can easily see that h is actually y square divided by 2 plus u of x, where my u of x is nothing but this is x cube divided by 3 minus x square divided by 2. Okay, so then we can see that y square is actually 2, so we can say that this is y square is actually 2h minus u of x, and then from there we can say that plus minus square root of 2h minus u. It has two copies. Now but definitely we can first draw u of x, the graph of u of x. And we can use the basic calculus to draw that, and we can use first derivative test, where is it maximum, where it is minimum, and all that. Okay, that's very easy. So I'm not gonna do that. I'm just gonna draw this for you, and then you can verify that actually. So this graph is actually showing me that, okay, this is increasing from minus infinity to 0. Okay, and then this is 1, suppose this is my 3/2, and then it is decreasing until 1, and then it starts increasing, and it increases up to infinity. Okay, so this is what u of x is. But now we are going to use this u of x to draw the face portrait. Okay, that's called a projection method. Okay, so we are going to go to the new page. Okay, so this is my, suppose this is my u of x. Okay, so this is 1, and this is suppose 3/2. Okay, so this graph is increasing, and then it starts decreasing, and then again it starts increasing. Okay, so my drawing is not good, but this is u of x. Okay, this is u of x. Now correspondingly, so definitely this is x, and this is u of x. Okay, so now right below this graph, I'm gonna actually sketch the graph. Okay, so now we will consider different edge curves on the ux graph, and then we will actually project that. So if we see that, suppose this is my edge curve. Okay, suppose this is my h1. Okay, so now we can see that this is the point where my u of x and h are same. So this means that my y will be 0, because my y was plus minus square root of 2 into h minus u, and y is defined whenever h is greater than u. So definitely we need to consider the value of u that are below h, because that's where y is defined. So now we can see that this at this point my y is 0, so this point will be projected to this point. Okay, 0 point. And now we can see as h is increasing, my y is also increasing, so this definitely this is increasing this way, but it has 2 copies, so the reflection part is this one. We can see that. Okay, that's for sure. Now suppose this is my second h curve. Okay, suppose now this is my h2 curve. So if h2 curve, we can see that this point where the u and y are h are similar, so definitely my y will be 0, so this point will be projected to this point. Now you can see that as my h2 is increasing, as my h2 is increasing, y is also increasing, so this is increasing this way, and because it has 2 copies, so it will be this way. But now we can clearly see that, since because this part is also less than h2, so definitely we will also, so definitely this point is gonna be projected to this point, and this point is gonna be projected to this point. Okay, but now we can see that as my h is increasing, my corresponding value of y is also increasing. Okay, but since this is increases here, and then as my h starts decreasing, my y value will get also smaller, and so definitely this is the second copy. Okay, now suppose if this is my h3 curve that is passing through the horizontal x-axis, so definitely this whole part is less than h. okay, this whole part. So definitely is my h is increasing, my value on y is increasing, so it will be increasing this way, but it has two copies, so this way, and definitely this is projected to this 0 origin. And now we can see that also this part and this whole part is below this h3 curve, so we can see that this will be projected to this. So now as my h is increasing, my corresponding value y is increasing, it increases to this point because this is where, and then as h starts decreasing, y value will be decreased, and this is since h3, so this will be it, and it has two copies. So we can clearly see that. Or now suppose if we have this h4, okay, so now as h4, so we can see that this whole graph is below. So if we can see this whole area is below h4, okay, so we can see that now over here as my h starts increasing, my function value is also increasing, but it increased to this point, and then from there it is increasing up to this point, so definitely it is increasing up to this point, and then again is my value of u is decreasing or h is increasing, this is increasing, so this will be this way, and because it has two copies, so definitely it's gonna be this way, and then finally it will go this way. And this process actually, this process keeps, keeps moving, okay. But now definitely we are gonna see the flow direction, that which way this the flow of the solution is okay. So since we know that x dot is actually y, okay, x dot is equal to y. Now if y is positive, then my x dot is positive, so this means that definitely over here my y is positive, so my x dot is positive, so x dot is positive means this is going this way. And if y is decreasing, x dot should be decreasing, so now over here y is decreasing, y is negative, so x dot is negative means x dot is moving to the left of the origin. So you can see that now, so you can clearly see that this is this thing, you can clearly, I don't know why this pen is not working, okay, so you can see that this, okay, but this is this thing, this is this thing, this is this thing, so this is going this way, 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 okay. So you can see that the flow of the solution, that okay, it is starting, you can see the flow of the direction, it is totally correct, okay. So it's starting and then it goes there and then so this is the phase portrait of the solution. And I hope you understand this problem well, and if you have any question you can just ask in the comments, and thank you.